In this video, I will explain the basic behavior and functioning of a neural network so that we can actually start implementing it. So if you are familiar with the way a neural network works, if you know what the layers are, what the weight matrices are, what the bias vectors are, please feel free to skip this video. Otherwise, just bear with me for a second. And so let's make a diagram to help me explain you what a neural network is and how it works. I'll be drawing a couple of circles. These are what we typically call the neurons in the network. And so the idea is that in a way, in a very basic way, a neural network mimics the functioning of a human brain. And so let's just draw some, oh gosh, this is terribly small. I need a larger rubber. Okay. So let's say we have this neural network with 3 neurons at the back, at the input layer. These rectangles represent the layers. Then we have 6 neurons in here at this intermediate layer, sometimes also known as a hidden layer because it's neither the input nor the output. And this is the output layer. And let's say this neural network in particular is trying to guess if something that is coming in at the left gives, say, information about a cat or a dog. So whatever is coming in, maybe this is the weight of an animal. Now this is terribly big. Why does this have to be so hard? Let me make this smaller. Okay, so maybe in here you're getting the weight of an animal, in here the height, and in here, I don't know, the number of hairs the animal has. Who knows? I have no idea. And then this neuron at the top is going to say if this is a dog, and then the neuron at the bottom is going to say if this is a cat. So basically we want to distinguish between cats and dogs based on the weight of the animal, the height of the animal, and the number of hairs. Okay, and so what is actually happening here? This neuron over here is going to ask the neurons that are behind him, so these ones, what these neurons think the inputs refer to. So if these neurons think if it's a dog or not. And basically, like it would happen in real life, if you trust someone a lot, maybe that person's opinion matters a lot to you, right? Maybe if you only trust that person a little bit, the opinion matters just a little bit, as represented by this thin line. Maybe if you trust someone an awful lot, their opinion matters a lot to you. And maybe you might even not trust a person at all, and maybe that person lies a lot, and so if that person says it's a dog, then maybe it's because it's not. And so basically this neuron over here that decides if we are talking about a dog or not is going to ask these neurons that are immediately behind him, what do you guys think? And then the dog is going to take all these opinions into account, it's going to weight them, and then it's going to take into account its own opinion. Of course, when you ask for opinions, you want to know what people think, but you usually also think something yourself. So you weight all these opinions, you take into account your own opinion, and then you make a decision. And this also happens for the cat. I'm not going to draw everything, but the cat also asks for these opinions, and then these neurons tell the cat neuron something, and then the cat weighs these opinions, adds its own opinion to the mix, and then decides something. And well, how do these neurons over here form their own opinions? Well, they're going to ask the neurons that are immediately behind them. So all these neurons are going to ask what all these inputs have to say, and then they are going to weigh all these opinions, and then they are going to add in their own opinion on the subject matter, and then they make a decision, and then they inform the neurons at the front. So just to go over this again, something comes in at the left. These input neurons, because these are the ones that got the inputs, give the information to the next neurons. These neurons weigh all these opinions, add their own opinions, and then give some information to the final neurons. The final neurons weigh these opinions, add their own opinions, and then give something as output of the network. And factoring in all these opinions that all these neurons have is done by means of matrix algebra. And let me just add one more link here, okay, so that it becomes clear that all these receive from all these on the left, and then these neurons here receive connections from all of these neurons. And these connections, these levels of confidence, as indicated here by the colors and the thickness of these lines, these are going to be modeled by weight matrices that we are going to represent with a W, as in weight. And then my own opinion, so the opinion this neuron has on the subject, the opinion this neuron has on the subject, the opinion each neuron has, is going to be modeled by a bias vector, which is going to be represented by a B. Okay? And what this means is that we are going to need a weight matrix here, so let me call it W1, to model all these interactions here. We are going to need a weight matrix here to model all these interactions, let's call it W2, and then we are going to need a bias vector in here, let's call it B1, and, gosh, that's a terrible one, and then a bias vector here, let's call it B2. We don't need a bias vector in the input layer because, well, the input is just the input. There's no need to opinionate on top of it. And so what we are going to do next is create these matrices and these bias vectors. And we are going to do that in the next video.